Okay, let's start example number 2. This one is a water balance in a swimming pool, and you've been given a table of how many inches of evaporation occur each day over a 10-day period. We know the measured level at the beginning of the 10-day period, and we know the rainfall, the daily rainfall as well. So we're given that we've got a swimming pool that is 20 by 20 by 5 feet. So here's our swimming pool. And so it's 20 by 20 and 5 feet deep here. And we know it has a leak at the bottom. That is an outflow to the pool. And we know there is some precipitation into the pool, and we know that there is evaporation out of the pool. And there's some change in storage, which is represented by the water level, and the water level went from 60 inches to 52 inches. So that means that our change in storage is negative. So if the water level goes down, that means there's less water at the end, and so the storage decreased, and so we have a negative change in storage. So if we set up our water balance equation, which we're always going to do in minus out equals change in storage, our inflow here is our precip, and our outflows are the evaporation plus our leak, and that's going to be equal to our change in storage. And our leak is our unknown, so we're going to solve for our unknown. So we're going to solve for our leak, and that's going to be equal to P minus evaporation minus our change in storage. So this is the equation that we need to solve. So so over the 10-day period, like I said, we're given a table with, and you're given a table also, with daily evaporation. So our delta T, let's make our list of what we have given now. We're given our time period. Delta T is 10 days. And we're given that our evaporation over this 10-day period, if we sum the daily values of evaporation, we get a total of 3.5 inches. So on day 1 it was a half an inch, day 2 0, day 3 a half an inch, day 4 0, and if we sum up that column of evaporation, daily evaporations, we get a total of 3.5 inches over our 10-day period. Our precip over this 10-day period, again, same thing, you're going to sum up that daily column of precip, and we get 7.0 inches. And then the other thing we need is our change in storage, delta S, and we're given that we know that the level of the pool at the start is 60 inches, and at the end of the 10-day period it's 52 inches. So our change in storage is minus 8 inches. So this one's pretty simple to get the amount of leak in inches now. So we can plug this in. I'm just going to add this in here. So we get our precip is 7.0 inches minus our evap, 3.5 inches. And this is tricky. Notice we have minus our change in storage, but our change in storage is negative. And so we're going to say minus 8 inches. So we end up actually adding the change in storage in here. And what we end up with is that our leak is occurring at a rate of 11.5 inches over a 10-day period. So 11.5 inches over 10 days is 1.15 inches per day. So there's our leak. But we want to know our leak in how many cubic feet per day. So now think about this. We have just over an inch of water over our swimming pool. To get the volume of water, we want to multiply that depth times the area, right? And the area, so our area of our pool is 20 feet times 20 feet, so that's 400 square feet. So the area of our pool is 400 square feet. So now to convert our leak from inches, we're going to multiply by 400 square feet, and then we also have to convert our inches into feet. So we'll divide by 12 inches per foot here. And what we end up with is 38 cubic feet per day is the amount of the total volume of water that is leaving our swimming pool over that, leaving the pool per day over that 10-day period. So again, let's compare the magnitude. So our precip in was twice than the evaporation out over that 10-day period, and the leak was greater than either of those. So more water leaked out and evaporated out than rained in, which is why the water level was dropping in the pool.